Greetings, young mathematicians. Welcome to Saxon Math Lesson 100. What? Estimating square roots, irrational numbers. Okay, starting out with positive, negative. Well, two negatives do make a positive. So really, we're looking at 1 5/10 plus 7 5/10, or 1/2 plus 7 1/2. Negative 1 1/2. So we can think of it as 7 1/2 minus 1 1/2, which is 6. Order of operations, exponents. Well, 5 times 5 is 25. And if we were to just do these exponents together, we are adding them together since we're multiplying. It would be 10 to the negative 10 power, but we want to express ourselves in scientific notation. So we can say 2 5/10 times 10 to the negative 9th power. That way we can put our decimal point in there. Okay, algebra. We can look at this right away and see that we should add 10 to each, or 20, to each side. So we can immediately make that 120 equals 5W. And so, 100 would get us to 20. And then the other 20 would get us 4. So 24 equals W. Convert negative 20 Celsius to degrees Fahrenheit. Multiply by 1.8 and add 32. Trying to come up with a jingle to help remember that. Just looking at that, I can see 36, and I need to put a decimal point in here, and or do I? And then I add 32 degrees. Of course, this is a negative number, so that will get us negative 4 degrees Fahrenheit. Calculation, 20 times 3 3/4. Well, I can see the 60 right there. And then 3/4 of 20 is 15, getting us 75. $33 1/3% less than 24. Well, that just means subtract 1/3, and 1/3 of 24 is 8. So that will get us $16. Geometry. What shapes has no vertices? I believe that they are merely referring to three-dimensional. So, well, that's a circle. Not sure if I can do any shading to help that out. No, that's all terrible. Imagine this is three-dimensional, and so that would be a sphere. Has no vertices. All right, calculation. 25% of 44 is 11. Times 3 is 33. Minus 1, 32. Divided by 4 is 8. Times 7, 56. Minus 1, 55. Divided by 5, 11. Times 9, 99. Plus 1, 100. Square root of 100 is 10, minus 1 is 9, square root of 9 is 3. All right, well, let's look at lesson 100. Estimating square roots. And speaking a little bit about irrational numbers. So if we're looking at counting numbers that are perfect squares, you say 1, 4, 9, 16, 25, 36, 49. You get the idea. But what happens if we need to figure out the square root of something that's in between a couple of these? Such as, what do we do with the square root of 29? Well, it's all about guesstimating, which is like estimating, except you're guessing a lot more. And then just seeing if you're right. So the way we can do that is we can think, well, we could look at the square root of 25, right? So that would be 5. And we can look at the square root of 36. Which of course is 6. So essentially we know that the number is going to be between 5 and 6. So while it's a little tricky to figure out exactly what that number is, we can guess of where it is located on a number line. Which is to say, well, 29 is closer to 25. So we'll put our square root of 29 a little bit closer to 5 on the number line. So looking at example 1, between which two consecutive whole numbers is the square root of 200? Well, we remember that square root of 100 equals 10. That's kind of tiny though. So maybe we could think of just doing a little guesstimation. Well, if there's 10 times 10 is that. Maybe if we tried 20 times 20 equals 400. No, we way overshot. So maybe go down to something a little more in between. We could maybe try 15 times 15, which we've had a lot of practice with lately. By now, hopefully we remember that it is 225, but we're still too big. So maybe we could guess down to 14 times 14, which is 196. So we do have our two consecutive numbers. So we can say that let's make that look more like a 4. We can say that the square root of 200 is greater than 14 and less than 15. And so if we want to bring that down to a smaller example, whoa, that was meant to be a line. We could look for the square root of 10 by thinking, well, square root of 9 equals 3. And the square root of 16, which is our next counting one, is 4. So we can say that the square root of 10 is between 3 and 4. Now let's go back and look at our 29 example. Because if we actually do this out on a calculator, we actually get to the square root of 29, and I'm going to just do a 5-point blah, 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 so that I'm not trying to parse exactly what this number is. So square root of 29 equals 5.385164.8, which is pretty unwieldy. And also the fact that if we start multiplying these, if we were to try to multiply these together to get 29, we can look at our first two. 8 times 8 is 64. We're going to end up with a point blah, 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 or won't be zeros, but blah, 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 4 as an answer. So we can say that this is not just improper. This number is irrational. Irrational. So therein lies the path of madness. So thinking of the difference between rational numbers and irrational numbers, and we can also look and, do a reasonable estimate of where they are on the number line. So looking at pi is irrational number. But we can say that it's a little bit more than 3. 3 and 14/100ths is a good basic thing to work off of for that. Now, looking at the square root of 2, we are going to end up with an irrational number. That's going to be very hard to puzzle out. So, but we can think of that as, well, that is somewhere between 1 and 2. It'll be 1 point something something times 1 point something something. So we'll put that one right there. Say you are the square root of 2. Now, looking at our next number, it's 2 and repeating 3. Now, that's not as tricky as it might look to figure out, because really that's just 2 1/3. So that is a rational number, because we can, even though it's a repeating number, we can express it in the form of a fraction. So that makes it rational. And so we'll put that at about 2 1/3 of the way up there. And then finally, we've got, -1/2, which I guess they just decided to add that in there for spice. We can just go a little bit below the number line, find a halfway point, and put that there. Okay, and that's pretty much what Fantastic Lesson 100 is really all about. please do the practice set, and I will meet back up with you again at 12:45. Have a wonderful day.